rectangular garden. Okay, if this is the width, the length of the rectangle is 4 more than the width. Okay, does that make sense? 4 more than the width. Determine the dimensions of the garden if the area is 117 meters squared. Okay, so what do we know about the area of a rectangle? So a rectangle area is the length times the width. That's how we get an area of a rectangle. Now, what I'm going to do is line this up with our quadratic ideas. When we have quadratics, we have a y and then a bunch of x's kind of idea, right? So I can't have 2 different letters. So I'm going to take this and replace L. Is that legit in math? Can you make a replacement? If it's equal, you can replace it. Okay, so the area equals the length replaced times the width. Okay, and now I'm ready to put this into my calculator and let the calculator do the work. Okay, so y equals, I'm going to go bracket x plus 4 times an x. I don't know here. Well, we want the area to be 117, so let's go to our window here. I probably am wanting my y max to be 150 or something, just to make sure it gets past 117. So I did the normal x, I just tried negative 10 to 10, and then y is the area, so I went from negative 25 to 150. Okay, and then I did scales of 25, and we'll see. Okay, not bad. Okay, my goal is to get an area of 117. So I'm going to go y2 and make the area 117 on the y2 graph. So that's what it looks like, the area. So when does the parabola, which is the area, when does it equal exactly 117? And I'm going to get it here. And I'm not going to do this one because then I would be answering with a negative width. We can't answer like that. That's not possible. Okay? So we're going to do that. I'm going to get my mouse. Here's my trick. I'll show you this trick. I know that I need my mouse closer to this, so I'm just going to put like 8 or something like that. And boom, my mouse is for sure closer over there. So if you can just hit trace a number that you think, enter, then you don't have to keep scrolling your mouse. Okay, so now I'm going to go second calc, intersection, enter, enter, enter. On my calculator, it's x equals 9. That's what my calculator is. But in this situation, what is x? We don't have x, we have the w. So we need a width of 9 meters. So the width will be 9, which makes the length what? the length has to be 4 more, so that would be a length of 13. Okay. The water rocket is the next one we jumped over. A water rocket was launched from the ground with an initial velocity of 32. The rocket, so there, that's where it gets launched from, right at the ground. At a time of 0, we're going to be doing the height of the rocket. The rocket achieved a height of 44 when it was 2 seconds into the flight. Oh. I guess I don't know that that was the top height. So then I also know that it was in the air for 6 seconds. I think that's the idea. Okay, so the rocket went up. After 2 seconds, 44 was its height, and it was in the air for 6 seconds. So this is where it hits the ground. Determine the equation, and we're going to figure out the domain and the range. Okay, so 2 lessons ago here, we learned equations. So I gave you this. I should probably give you a nice sheet where it's all just on there. So which form do you think I'm going to go with? General, factors, because I know x-intercepts, or vertex form because I know the vertex? What do I know? Do I know the vertex, or do I know stuff about x-intercepts? X-intercepts. Okay, so we're going to pick factored form. I'm picking factored form because I can see 2 of the x-intercepts. Okay, so first of all, let's just think about what our factors are. So if you were to have an x-intercept of 0, your bracket would just be x, or x minus 0, but we don't need to write it. And if you had an x-intercept of 6, then your bracket would be x minus 6. Okay, now I would like to figure out what the slope is. I can tell that it's going to be negative. And I'm going to use this point and plug it in to the x and y, and then I'll figure out my a. So y is going to get replaced with 44. X is going to get replaced with a 2. Okay, so now to do some algebra, 2 times negative 4 Okay, so I timesed all that together, and then I would have had to do a division. And it makes sense that it's negative because I can see how it would be opening. Okay, so now when I go to type this in, remember every time you're typing it into your calculator, you need everything except x and y have to be left open. So my calculator would be y equals negative 5.5 x minus 6. Okay, so in factored form, you're going to need the slope and the factor brackets. In vertex form, you're going to need the slope and the vertex. Okay, always leaving the y and the x as y and the x in the final calculator stuff. Okay, state the domain and the range of the variables. Well, with what we already had, what's the domain for time? What's the time? Time can go from what to what? 0 seconds to 6 seconds. That's the domain. And the height, which is the range. So the lowest height is the ground. The lowest height is the ground. And the highest height would be here, which I don't know. So now I'm going to go into my calculator. I'm going to go negative 5.5 bracket x minus 6. Okay, let's think about our window. So if this was a height of 44, what do we kind of want as our max height? Maybe 60? I'm going to go up by a scale of 10 on the max, on the height stuff. I don't know, we just graph it and we see if it works. Yep, I think it's pretty good. Okay, so look at that, 2, 44, 6, 0, that stuff was all there. Okay, so get me my max. So second, calculate max. I'm going to go like this. 2, enter is on the left. 5, enter is on the right. Instead of doing my scrolling, I kind of do that because it's a little bit faster if I know. 49.5 is the highest height. Okay, let's go one more today and I'll let you work. Let's go to the last one. Okay, we have somebody going off of a diving board. Okay, here's what's happening. The diving board is a 7.5 meter platform. So they're right there. What happens when you are on a diving board? You jump upward, right? And then you eventually fall, and then that's where you hit the water. What is this math coordinate? If you're on a 7.5 platform when you start, the time is 0, the height is 7.5. Okay, so that's kind of what I'm thinking. The time is the height, or the x, and the height is the y. He reaches a max height of that after that. So this coordinate is the vertex, the max. How long does it take him to reach the water? So that's the question mark. Okay, so we do not have an equation. So when I gave you all these equations the other day, which one should I use? Basically, when we're making them, you have two choices. Do we have x-intercepts for factoring, or do we have a vertex for vertex form? So vertex, because we have the vertex. Okay? So there's the equation we're going to be working with. Okay, so we know that we're going to plug in because we have to figure out the slope. So the vertex goes into the h and k spots. So this is going to be a minus 0.3. And this is a plus 7.94. Okay, that's the h and the k. And then the x and the y, I can put in a point if I know another point. And I do know another point. I know the y-intercept. So I'm going to replace this y with 7.5. I'm going to replace the x with 0. Okay, I'm going to subtract that out of there with algebra. I'm also going to do this number squared. So 0.3 squared is 0.09. So dividing by 0.09, negative 4.89 is the slope. I knew it was negative because of the situation, right? It has to be upside down. Okay, so when I go to type it in, remember I'm going to use this and leave the x and the y open now. So y equals negative 4.89 x minus 0.3 squared plus 7.94. So it has the vertex and the slope, and the x and the y are left open for my calculator. Okay, we'll go to our window here. Now let's think about what do we want to do for our x window? Because this time is only a 0.3. So time is really small. So do you want to go from like -1 to 2 or something like that, really small? I don't need much time because it's 0.3 seconds here, so that's not much. So we'll try something like that. What do you think we should go with our y window? This is the highest height, basically like 8-ish. So should we go -5 to 10? Is that okay on the heights? Does that make sense? So window, I'm going to change all those things. See what happens here. We can adjust it after, right? Don't need much times, -1 to 2. And the highest it looked like the jumper went was 8-ish, so. Okay, now here's where they hit the water. So I'm going to left bound it and right bound it and figure out that 0. So calculate 0, left bound, and then you can go right. .57 seconds, that's how long it takes. And then they hit the water.